Welcome class to Chapter 9 classes. In Chapter 9 we're going to look at Object-Oriented Programming, or OOP. OOP is one of the most effective approaches to writing software. In OOP we write classes that represent real-world things and or situations, and we create objects based off of these classes. When you write a class, you define the general behavior that a whole category of objects can have, and then we create individual objects from that class. Each object is automatically equipped with the general behavior, and then we can then give unique traits. So think of a class as like a Microsoft Word template. We use the template, it has its basic traits, and then we can go ahead and customize and give it our unique traits. Making an object from a class is called instantiation, and you will work with instances of a class in this chapter. So I'm going to break up Chapter 9 into 3 separate videos. We're going to cover the first 2 objectives in this video: creating and using a class, and working with classes and instances. So definition again of classes: represent real-world things and situations. You create objects based on these classes. When you write a class, you define again the general behavior. We want to make it behave like a template. And then when we instantiate the object, we get those general behaviors, and then we can go ahead and then customize our copy to what we need it for our purposes. You create instances of classes, again, like copying a template. Creating and using a class. Again, you can model almost anything using classes. In our chapter, we are going to create a class called dog. Not one dog in particular, but in general, what properties or what methods would every dog have? Well, every dog would have a name, every dog would have an age, every dog could sit or roll over. So here is our class dog. Just notice again the syntax of the name of the class is camel case, meaning we capitalize the first letter of each word. If we had any parameters that the class needed, they would be stored here inside of the parentheses. We have a docstring that follows class and then the name of the class and the colon, and that just gives a comment about actually what this class does. We have the init function. And in this example, we have a sit method and a rollover method, or maybe we can call them functions. They're the same thing. Functions and methods, they just do things. In the init function, we create our properties or our variables that we'll be using. So more on the init function. Notice the 2 underscores before and the 2 underscores after, and we've learned that through alien invasion. The init function runs automatically whenever we create an instance based on the class. Okay, keep that in mind. The self parameter is required and must be first. Every method call associated with a class automatically passes self, which is a reference to the instance itself. And I know that's a loaded sentence, and we'll look at examples and hopefully that will clarify. It gives the individual instance access to the attributes and methods in the class. Okay, and we'll be looking at examples there too. So we send along parameters, and then we go ahead and assign parameters to those attributes that are part of the init function. So let's look at an example and kind of unravel this slide. And we'll go back to our dog example. So class dog, we got our docstring, init function. Here's the self parameter, again giving access to the instance itself, and then we have a name and an age. So when we create an instance based off of dog, we are going to send along the name and the age. And then that is going to be stored in our attributes name and age, self.name and self.age. So let's go ahead and just look at an example of that. Okay, so here we have my dog equal dog. This is my class name here that matches up here to the class name. I'm sending along the name and the age, and the instance name in this case is called my dog. Okay, gets all of the behaviors of this class. So it inherits these attributes as well as the sit and the rollover methods. and that is in this example right here. So what function is automatically called in our class of dog? Well, that would be the init function. What is the instance name? The instance name is what you'll find on the left side of the equal sign. And then what are the attributes? Well, the attributes are what is automatically created in our init function. So that is self.name and self.age. After we create an instance from the class dog, we can continue to use dot notation to call any method defined in dog. So looking at this example, we have sit and we have rollover. So down here I have those in lines 22 and 23. So my dog, again, the instance name, okay, followed by the method that we're calling. When I refer to the attribute, I use my instance name along with the name of the attribute. So let's go ahead and run this and let's see what our results are. So my dog's name is Willie, that's what I sent along. My dog is 6 years old, 6 years old. Willie is now sitting because that's the print statement here. And then Willie rolled over. Creating multiple instances. So if I wanted to create another object based on my template class, I can go ahead and do that. So I'm going to do this example, and I'm just simply going to copy what I have right here. And instead of my dog, I'm going to create an instance called your dog. And your dog is going to have, just looking up, Lucy and 3. So Lucy, I guess they actually have these capitalized. In the older version we used title to get them capitalized. So Lucy and 3. Now when I refer to this instance with its attributes or even the methods, I have to use that name. So your dog.age, and then when I want to use it here with the methods, again I just replace my dog with your dog. So if I chunk these all together, bring them in two big blocks here, you can see I have an instance called my dog, copy of this template. Go ahead and run, get the attributes and the methods, and then I just create another copy, or another object called your dog. So my dog's name is Willie, 6 years old, my dog's name is Lucy, and so on. You can create as many instances as you need for your program based off of classes. Working with classes and instances. So before I jump into this, I want to look at the labs that are from the first section. So 9-1, restaurant. Make a class called restaurant. The init method for restaurant should store two attributes, a restaurant name and a cuisine type. Okay, so two attributes for restaurant. So right now in our dog example, we have those two attributes. Okay, so you're just going to name them differently. Make a method called describe restaurant. So that instead of sit, we would have describe restaurant that prints these two pieces of information, and a method called open restaurant that prints a message indicating that the restaurant is open. So we're going to have two print statements in our describe, and then in our open restaurant we're just going to have one print statement. Make an instance called restaurant from your class. Okay, print the two attributes individually and then call both methods. Okay, so use your dog example as a way to run through 9-1. Then in 9-2 we have three restaurants. Start with your class from 9-1, create three different instances from the class and call describe restaurant for each. So here we have two different instances, my dog and your dog, so I just would have an additional third instance in that 9-2 lab. Working with classes and instances. So we're going to jump in now and look at the car class, and we're going to use this car class kind of throughout the rest of the chapter. So a simple attempt to represent a car. So we can give general attributes such as make, model, and year, And when we when we create an instance based off the car class, we send along make, model, and year. Okay, so we get these attributes populated. We have one method called getDescriptiveName, and then notice again self properties on both of these. And this one just creates a variable called longName and brings in the year, the make, and the model, and then we go ahead and return that back down to our instantiation line, which is my new car. Okay, so this is going to be our new instance name, my_new_car. Okay, so here is that example. So send along Audi to make, A4 to model, year 2019, and then we use the instance name to call the method getDescriptiveName. And there's our result, because we created this string of year, make, and model, and we returned that back down, and then go ahead and print it out. Let's look at how we can set up default properties. So setting a default value for an attribute. So in our init function, we can specify an actual value to be associated with an attribute. So then you do not have to include the parameter for that attribute. So we have make, model, and year. We also have odometer reading, but notice that we don't have it here in our parameter list because we are assigning a default value to it. So let's go ahead and add in that default. So self.odometer reading equal 0. We are going to add a new method, and that method's name is going to be read odometer. If I can type it right today. Self parameter, our docstring, can't type. Okay, so now in addition, I can use my instance name, call my new method, read odometer, and now I have that output of my print statement. This car has 0 miles on it. Okay, so just an example of, again, setting a default value for an attribute. So how do we modify attributes? Well, we got 3 ways that we can go about doing this. We can change the value directly through an instance. So in this case, we have the instance name myNewCar. We use the attribute odometer reading. We assign it the new value of 23. And number 2, set the value through a method. Okay, so we could use a method called updateOdometer, and we would actually update the value of this attribute. We can also increment the value through a method. So we go ahead and just add on what's already existing in the odometer reading attribute, and we add 100 to it. So let's look at all 3 of these examples. So on page 164, we are going to go ahead and do the first example of modifying attributes value directly. So before we call the read odometer method, we are going to set our new value. So using our instance name, using our attribute of odometer reading, we assign it 23. Go ahead and drag this down here a little bit. So now it shouldn't be 0 that's printed out, it should be 23. This car has 23 miles on it. Okay, modifying an attribute's value through a method. So now we're going to create a new method called update odometer. So in our update odometer, we also have a second parameter beyond self. We have mileage. So whatever is sent as an argument to the parameter mileage, it then is going to be stored in odometer reading. So let's look here. We have my new car odometer, update odometer. We send along the value of 23. Okay, so calling update odometer, 23 stored in mileage, 23 then assigned to odometer reading, and then again read odometer is going to print that out. So the same results, we get 23 miles on it. We're going to add a little logic in update odometer in our example on the bottom of page 165, okay, so that no one can roll back the odometer. Okay, kind of a practice back in my early years when you could actually do that with some cars. So if mileage is greater than or equal to the current odometer reading, we can go ahead and then update it. Else, hey buddy, we cannot. You cannot type today, Amy. You cannot roll back an odometer. Okay, so let's imagine that our odometer reading was set at 23. We're sending it through here. Let's go ahead and change this up here to 100. Okay, so odometer reading 100. We're sending along 23. Let's see what happens. You can't roll back an odometer. This car has 100 miles on it. So we're not allowed to send along a value that is less than or equal, okay, less than the odometer, the current odometer reading, with our logic that we established there. Now if we have that, it goes ahead and lets 23 miles on it because 23 is greater than 0. Okay, last example. So incrementing an attribute's value through a method. Okay, so we've got now a new method called increment odometer. Good practice here on getting to create new methods. And I know that you guys have gotten that experience with Alien Invasion. Okay, so an updated odometer, we're going to send along 23,500. Remember back when we were looking at integers and how we could use underscores in place of a comma? That's all that syntax is doing there. And then we're going to, let's go ahead and run this. So this car has 23,500 miles on it. Now we're going to go ahead and update that. So we're going to increment. So my used car, or my new car, increment odometer, and we're going to increment it by 100. And now we have the updated miles with 100. Okay, so let's look at our lab for 9-4. Before I do that, make sure that I don't have, yeah. So that ends this video. So looking at our lab, page 167, 9-4, number served. Start with your program from exercise 9-1. Remember, we're creating the restaurant class. Add an attribute called number served with a default value of 0. Okay, so no different here, default value of 0. Create an instance called restaurant from this class. Print the number of customers the restaurant has served, and then change its value and print it again. Okay, so any one of those methods that we just kind of reviewed. Add a method called set number served, so you're going to be adding in some methods that lets you set the number of customers that have been served. Call this method with a new number and print the value again. Then add an additional method called increment number served that lets you increment the number of customers who've been served. Call this method with any number you like that could represent how many customers were served in, say, a day of business. So we did this all through our car class example. If you have any questions on what we went through today in this video, if something is just not clear to you, please let me know. If you have any questions on the 3 labs that are part of this section, send me an email as well. I love to debug code, so please don't think that you're bothering me in any way. Thank you.